So welcome to the next program. So that is design, develop, code and run the program in any suitable language to solve the commission problem. Analyze it from the perspective of equivalence class testing. Derive different test cases. Execute these test cases and the test results. So before writing the program, definitely we need that requirement specifications. So we already know that in the commission problem. So that is the commission problem includes a salesperson in the farmer origin territory sold rifle logs, stocks, barrels made by the gunsmith. So these components cost is to be log cost is to be 45, stocks 30, barrels 25. So the salesperson had to sell at least one complete rifle per month, and the production limits were such that the most salespersons could sell in a month, that is a log 70 logs, 80 stocks and 90 barrels. So here we computed the salesperson's commission as follows. So that is on sales up to and including 1000, that is a 10% commission. On sales up to and includes 1800, that is 15% commission. On the sales in excess of 1800, so the say commission is 20%. So here after the requirement specification, come to the design or algorithm. So we are in starting we define the log price, stock price and the barrel price. The log price is to 45 per each, stock price is 30, barrel price is 25. So we give the input here. If the input is to be -1, means that there is no logs, is not possible here, because the limit is to be 1 to 70 for the logs, 1 to 80 for the stocks, 1 to 90 for the barrels. So here log -1 means we exit the program here, because there is no input of logs here. If the input of log, stocks, barrels is to be there, we compute the total sales of logs, stocks and barrels. So that is we get the output in the step 6, that is the total sales. In step 7 we calculate the commission. If the sales is to be greater than the 1800, it go to the step 8, that is the commission equals, so 0.10 into 1000 means, so with the excess of 1800 means we calculate the 20% commissions for the excess of 1800, but before that we calculate including 1000 rupees, we calculate the 10% commissions. So then up to 1000 to 1800, that is the remaining 800 is 1000 we already calculated the 10% commission. For the remaining 800 we calculate the 15% commissions here. So after we get the answer some commissions, so commission plus the remaining amount, that is the excess of 1800, we calculate the 20% commissions. So sales minus 1800 here. So totally we finally get the total sales of all log, stocks and barrels here. So in step number 10, commission is 0.10 into 1000, that is the second one, there is a 15% commissions we calculate here in step 10. So in step 11 we get the commission of sales persons. So this is the program source code. So as usually we are defining the log, stocks, barrels, and we are defining the logs is a 0, and let's say if flag go to that is there is no stocks here. So same as algorithms, so we are defining that one, the total sales, everything is to be here. So in question, so come to the test cases, testing methods. We are using here equivalence class testing. That is the test selections using equivalence partitioning allows the tester to subdivide the input domain into a relatively small number of subdomains, that is n greater than 1 as shown in figure. That is we partition that one equivalence, we partition these sets using the equivalence class testing. So here in strict mathematical terms, the subdomains by definitions are destroyed. The 4 subsets shown in that one, in that figure A, that is the constitutive partition of the input domain, where the subsets in B are not. Each subset is known as the equivalence classes. So this is the example for the equivalence class testing. So come to the test case design. The input domain of the commission problem is naturally partitioned by the limits on lock, stocks and barrels. The equivalence, the input domain of the commission problem is naturally partitioned by the limits on lock, stocks, barrels. These equivalence classes are exactly those that would also be identified by the traditional equivalence class testing. The first class is the valid input and the other two are the invalid. The input domain equivalence classes lead to very unsatisfactory sets of test cases. Equivalences class defined on the output range of the commission function will be an improvement. So here, so this is the test cases for the commission using the equivalence classes testing. So in the first attempt we will have an 8-week robust test cases. So we already know that for the equivalence class testing, so there are 4 partition of sets are there, that is the weak normal, strong normal, weak robust, strong robust is to be there. For here we consider in the first attempt we consider the weak robust. In the robust means we give the robust, we give the excess, the large inputs is more than that one. For example, so 1 to 70 is to be logs is to be there, we give the values, that is the -1 and the 71 we will give that one, like that is the weak robust here. So in the 8 test cases, in the first test cases we give that weak robust is a 10 10 10. So this is the valid inputs are there. So definitely the total sales is to be 100, the commission is to be 10. So come to the second, third and up to 8th we give the values, that is the weak robust values, that is the minus values we are giving here, and also excess values are giving here. So here -1 for the logs. So this -1 is not considered here, that program is terminates. So based on our algorithm, the expected output is to be program terminates. So this is also same as the previous one. So in fourth one we give that 71, the log price is to be this is the out of range values, we give that one. So definitely varies the sales, total sales is to be logs not in the range because it give the 71, same as expected output. So here for the stocks we give the 81, the range is to be 1 to 80 only. So here 10 9 1 is the same, is a valid inputs we are giving here. We calculate the total sales and the commissions of that sales. So in the second attempt we give that finally the corner of the cube will be in 3 space of the additional strong robust equivalence class test cases is based on the previous one partitioning here. Then we give the strong robust values here. Strong robust means, so initiating with the weak robust values and we give the strong robust values means we give 2 out of range values for the inputs. So in first one the strong robust we give the -2 40 50 is to be same, logs values is to be the weak robust values, the sales is to be not in the range as expected output also same. So starting 3 we giving the same weak robust values here. So come to the fourth one, we give 2 input values are the out of range values, -2 -1 here. So here -2 -1 is out of range values, -1 -1 for the out of range values. So all 3 we give the out of range values. So this is the strong robust, starting with the weak robust and completed with the strong robust here for the test cases. So after the test cases we writing the expected output, the actual output and the status value we fill it after the execution of the program. So after execution of a program we will fill that one. So after that we execution test reports is to be there, number of test cases executed, number of defects raised, number of test cases passed, number of test cases failed. So these are the snapshots of the program. For example, enter the total number of logs 35 -1 45, it gives that invalid input. So like that 35 81 45 same invalid input because the 81 is out of range for the stocks. So these are the samples. 10 10 10 we give that one, total sales is to be 1000, the commission is to be 100 here. So these are the samples. Thank you.